Assalamualaikum warahmatullahi wabarakatuh to Prof. Abdullah B. Yassin. My name is Muhammad Mira Hakimi, and I am from Group 24, which is consist of 4 people, and 3 of my teammates is Faiz, Iftikar, and Awam. Me and my teammates of 3 people are presenting about the production of sagu. So enjoy. Introduction. So I will explain what is manufacturing system and a brief explanation about history of sagu. Manufacturing system consists of converting product into a higher value project through one or more processing and assembly operation. It is a mechanism which raw material are transformed to product. It is composed of human workers, automation, and various technologies for material handling, engineered in ways that produce unique categories of manufacturing system. The history of production of sagu. In 1850, people in Sarawak start to produce sagu by sending the raw material to Singapore to be processed. And in 1856, first factory was built in Kuching. Then the production kept growing until 2019. Sarawak government organizing project to plant palm tree in a large scale. Hence, in 2020, sagu production has developed widely in Sarawak with over 30 factories involved. So today, what is the issue? So a company faces a tough challenge with need to improve the production of sagu in order to be marketed in 2022. Me and my team as engineer assigned to this problem, we found that we need to do 2 tasks, which is design new plant layout for the factory, and the second one is renew the process for producing of sagu. So, this is the organization for the project. The head of the project is directed by the director of the company. Hence, under it, we have a manager, which is engineer 1, and under it, we have 3 more engineers to help organize the project.
Background. Sago is a type of starch that can be obtained from the pith of a type of tropical palm. The most common type of palm used is the Metroxylon sagu. The starch of the sago is extracted by first crushing the pith of the palm, then washing and straining the extracted starch from the crushed pith. The fibrous residue of the pith is then removed. The starch that was extracted is usually called lemantak in Sarawak. Sago is a staple food for people in certain regions, such as New Guinea and Moluccas, while also being consumed regularly by the people of Sarawak. The main supply of sago comes from Southeast Asia and in particularly Indonesia and Malaysia. Although it is consumed in various forms such as paste or pancake, sago can be usually found in the form of sago pearls, which is the product of our choice.
Manufacturing system. The manufacturing system will consist all 5 processes of the sago production, which will be fully automated, multi-station with fixed routine. This will increase the production rate of the sago as well as increase the efficiency of the production process while maintaining its quality. The sago production will start by mixing all the same ingredients to make the sago traditionally into the mixing machine. After that, it will be formed into a nice ball shape by using a snack making extruder machine. Then the sago seeds will go to the sieve machine to be sieved. The sago seeds then will be baked into the hot oven under the sufficient time in the hybrid turner oven. Finally, the sago seeds will be packed into a suitable size and amount and ready to be distributed to the market. Manufacturing process. The first process will start by mixing the ingredient to make the sago dough. The mantap flour, which is the main ingredient, will be mixed up with the other ingredients like rice bran, fried coconut paste, or kurise in Malay, coconut milk, and salt. To mix all of these ingredients, we will use the mixer machine, which is a WLDH horizontal ribbon mixer by the Zinyo. By using this machine, we can mix all the ingredients uniformly, as it is the greatest advantage of using horizontal ribbon mixer compared to the other type of mixer. This will help us to mix a large quantity of ingredients to make sago dough in a short time compared to using the human labor in the traditional way. The second process is rolling the sago dough to form a nice round shape of the sago seeds. In this process, we will use the puff snack making machine extruded by the muscle. We use this machine because it can process a food that have a similar dough texture as our dough. This will help us to make a more uniform, precise size and nice round shape of sago seeds compared to using the traditional way, which need to through many of the sifting and rolling process until they get a nice sago size. For the third process, the sago seeds will undergo a sifting process. ZX 520 linear vibrating sieve shaker machine by efficient can help us to segregate some of the undesired size of the sago seeds that been produced in the second process. This to ensure that we only get a nice sago size and shape. After that, the sago seeds will undergo the baking process without using any oil. In this process, we will use the hybrid tunnel oven from the company J7SRO. We use this hybrid tunnel oven because it can be constructed from the individual oven with direct heating, indirect cyclothermic heating, and indirect convection heating. This will reduce the baking time, besides ensuring that our sago seeds have been baked perfectly, which gives us a crunchy, dry baked sago seeds. Finally, the sago seeds will be packed into a suitable size of packaging. A ZV320A automatic filling packaging machine by the Cortem can help in packaging the sago seeds, as it packs from a range of 50 to 500 grams of packaging size, which is a common packaging size for the seed and snack in the market. This will help us to pack the sago seeds faster and accurate, as the filling process has been aided by the computer control system of the machine to fill the sago seeds into the packaging. And this is our end product, the pack of the sago seeds.
Human resources. The sago factory can be considered as a medium-sized factory that is designed on processing the lamantak into the final product of sago pearl. The amount of human resources used by the factory for the production line only requires a small crew. This is due to the usage of semi-automatic and fully automatic machines in the factory. This allows the labor cost to be smaller due to the smaller crew while maintaining the high production rate. Most of the human resources in the factory is used during the loading and unloading of materials, monitoring the machines during the manufacturing process, and final quality check before the product is shipped. The semi-automatic machines need to be monitored constantly, while the fully automatic machines is monitored periodically. This is to prevent the machines to be damaged further if it suddenly malfunctions. Maintenance is also done in regular intervals to allow the machine to last longer.
Hello, my name is Muhammad Shami. I will be presenting about material transport system. One of the most important thing about material transport is the way we handle logistics. The area of our business is more focused toward the local market, and maybe we will be immersing ourselves into the international market as our company grows bigger. Our target is mostly local people, which is within the country itself, or specifically from Sarawak. The mode of transportation is land transportation. The way we handle our material handling is by the use of Internet of Everything, which we can call it as transportation management system. It helps us to keep track of our goods and product and is specialized in planning, executing, and optimizing the shipment of our goods. TMS is essential for identifying and comparing the rates of price and service of the carrier, and be used for booking the shipment and monitoring its delivery movement and to monitor its delivery movement. Other than that, the benefit is to reduce and increase, which means reduce shipping costs and increase shipping quality and gain real-time visibility of supply chain. Furthermore, we get our customers' loyalty. The way we transport is by four-way, which is the use of non-powered tool, power tool, AGVS, and conveyor. Non-powered tool involve two-wheel hand truck, four-wheel dolly, which is more flexible if we consider some of the tasks is constrained by space. For power tool, we use forklift and lift truck. This is for more toward heavy lifting, and as our company grow, we would like to reduce our manual labor by considering the use of AGVS, which is automated guide vehicle system. For our material transport equipment, we mostly use conveyor belt as our main transport system. For our conveyor, the motion of the movement of material between machine is asynchronous, and in other words, the conveyor moves with a stop and go motion. The pallet move asynchronously carry the payload to the next station on the conveyor and can buffer before entering and exiting a workstation. Such systems are designed as a modular component families. This strategy provides a great deal of versatility in the implementation of conveyor system to satisfy any precise requirement. Other than that, our conveyor moves in a single direction. For our storage system, we utilize dedicated storage system. We store our material or raw material based on its number sequence and activity level, which is also based on market priorities. The most conventional storage method that we can think of is the use of the rack system. Rack system eliminates the use of large space inside our freezer, as less floor space is required to move the racks. And in the future, as our company grows, we might consider the use of automated storage system. We may utilize the partial or semi-operator to facilitate each storage or retrieval transaction.
Computer control system. All the five of manufacturing process of the Sago seeds production was using either semi-automated or fully automated machine. Every Sago production process was distributed into a different workstation, which using a different machine that capable to handle their own process. Therefore, all of the machine has different type of the computer control system, which needed an operator to handle the machine on every workstation. The semi-automatic machine are need to be given an instruction for them to work by controlling them manually, such as by using a button from the control panel. Meanwhile, a program can be downloaded from the fully automatic machine to operate themselves without operator to operate them. This can help the production can be done faster and efficiently in the term of production time, as well as the labor and the machine energy use. The computer control system can also help to control the material handling and transportation system to ensure all of them work as were coordinated in the order of and having an efficient processing mode. Some of the computer control system has a program that can diagnose any failure of the machine that was not worked properly and inform the operator to fix it. This will ensure the overall process of the manufacturing system work properly, efficiently, and safely, which will ensure the production on the schedule. By the help of computer control system on the machine, the quality of the product can also be guaranteed as the machine was not affected by any exhaustion or tension, unlike the human labor which will affect the quality of the product.
Identification system. So what is identification system? So it is a method on how to recognize our raw material, our part or our product even with the same shape and material. So firstly, identify the product and then linking it to only information that we need to link. We need to implement a sufficient identification system in order to work sufficiently. In our project, we implement a barcode inventory system to this factory, so it can track expiry date, batch number, serial number, or other information that we implement into the barcode. Also, it is also can be used in transportation process either within the factory or outside the factory. For the plan layout design, we have come up with this design for the new project. So this is the door. When the people come inside the factory, the first part they can see is the raw material storage. Then people go to the mixer machine for the first process, and next sieve the mixing sago butter, and then rolling machine, and then baking machine, and the last process is packing machine. After the product being packed, the product goes to product storage. And we can see every machine having one workers to work on it, except rolling machine because it is fully automated machine.
Conclusion. We can conclude that by applying the knowledges learned from manufacturing system, we were able to design and improve the production system of Sago. The benefit of the improved production system is the usage of semi-automatic and fully automatic machines in the production lowers the labor cost due to the smaller crew needed in order to operate the production line while maintaining the production rate of the product. The utilization of proper design of the layout of the factory will also allow the production rate to be increased by decreasing the amount of wait time between each production process of the product. All of this combined allows the production system to improve, which results in higher efficiency while minimizing the loss. That is all from us. Thank you.